afternoon, children. Welcome back to our online class. Hope you are well and safe at home. Now, today we are going to learn about that chemical changes. Okay, chemical changes. So, do you have interest to learn that portion? Yes. Let me start the class. First of all, we can learn or recall what we learned in the previous class. Okay. In the last class, we have learned about chemical equations. Chemical equations. So, what is called a chemical equation? A chemical equation is the shorthand form of representing a chemical reaction using symbols and formulae. A chemical equation is the shorthand form of representing a chemical reaction using symbols and formulae. Chemical reactions involve the conversion of certain chemical substances into some other chemical substances. The elements compounds involved initially in the reaction called reactants, and what is called products. The new elements or compounds formed are called the products. Then how to write the chemical equation? So few steps are there. Is it for that? So what's the first step? Identify the reactants and the products of the chemical reaction. Then second step, write the names of the reactants on the left hand side with a plus sign between them. Then write the names of the products on the right hand side with a plus sign between them. Place an arrow between the two sides with the arrowhead pointing towards the products. Replace the names of the products and the reactants with symbols and formulae. This gives the chemical equation. Make sure that the number of atoms of each element on both sides are equal. This is called what? Balancing equation. Next, we have learned about balancing the equation. How to balance the equation. Is it? For that also few steps we have learned. Is it? So we can see one of the example, that is magnesium burns in oxygen to give magnesium oxide. Is it? So here the reactants are magnesium and oxygen. The product is magnesium oxide. So the word equation is magnesium plus oxygen gives magnesium oxide. Then replacing the names with symbols and formulae, we get the chemical equation. The number of atoms of the elements are magnesium, that is number of atoms in LH is 1 and RHS is 1. Then oxygen is LHS 2, RHS is 1. So we have to balance the equation, is it? So Mg plus O2 gives 2 MgO. How we'll get this? Multiply RHS by 2. Is it? Now the number of oxygen atoms is balanced, but the number of magnesium atoms is not. Therefore, multiply magnesium on the LHS also by 2. So therefore, we'll get 2 Mg plus O2 gives 2 MgO. So this is the balanced equation. So magnesium plus oxygen gives magnesium oxide. Sodium plus chlorine gives sodium chloride. Aluminum plus chlorine gives aluminum chloride. Is it? Okay. So today we can learn about chemical changes. What is chemical changes? What is called chemical change? A chemical change occurs when two or more elements, more chemical substances react to produce a new substance with a different set of properties. So what is called a chemical change? A chemical change occurs when two or more chemical substances react to produce a new substance with a different set of properties. Chemical change is permanent, and such changes are occurring all around us, even within our body. So we can see some examples of chemical changes. The first one is reddish brown deposition on iron objects. You all know that reddish brown deposition on iron objects. Is it? Okay. So you must have seen that if you leave an iron object such as an iron lock out in the rain, reddish brown layer is deposited on its surface after a few days. This layer is called rust and the process is called rusting. The layer of rust falls off gradually, exposing fresh metal to further rusting. With the passage of time, the iron object becomes very weak. Okay, so what is called rust and rusting? So if you have leave an object, iron object such as trawl or an iron lock out in the rain, a reddish brown layer is deposited on its surface after a few days. This layer is called rust and that process is called rusting. Okay, so let's see what actually happens. Iron objects with atmospheric oxygen in the presence of moisture to form a substance called iron oxide, which we call as rust. Okay, so iron reacts with atmospheric oxygen in the presence of moisture to form a substance called iron oxide, which we call as rust. Okay, so the equation becomes iron plus oxygen plus water gives iron oxide. So what's the equation? Iron plus oxygen plus water gives iron oxide. So how this equation form, that is on the iron nail in the presence of oxygen and due to rain that water is there, is it? So when these three become get reaction between them, we'll get the product, new product as iron oxide. That's what the reaction, that word equation becomes iron plus oxygen plus water. So this is the reactant in the LHS left hand side, is it? Then arrow, then iron oxide. That's the new product we got, is it? So that is iron oxide. The chemical equation for this reaction can be represented as iron means Fe, is it? The symbol is Fe. Oxygen O2, water H2O. So the reactant side will get Fe plus O2 plus H2O gives iron oxide. What's the formula? Fe2O3 into XH2O. Okay, Fe2O3 XH2O. Okay, so this is the reaction, chemical equation. Okay, chemical equation for that reaction can be represented as Fe plus O2 plus H2O gives Fe2O3 into XH2O. Okay, rusting is a chemical change because the change is permanent. The change is permanent. You cannot get the iron back from the oxide. Oxygen and water are two essential conditions for rusting of iron. Absence of either or both of them can prevent rusting. Oiling iron objects protects their surfaces from coming in contact with moisture and air and prevents rusting. Okay, so oiling iron objects protects their surfaces from coming in contact with moisture and air and prevents rusting. Then what is called galvanization? Galvanization is a process in which iron objects are coated with zinc to prevent them from rusting. The water pipes used in our homes to carry water are made from galvanized iron. Okay, galvanized iron. So galvanization is a process in which iron objects are coated with zinc to protect them from rusting. So example, water pipes used in our homes to carry water are made from galvanized iron. Okay. So rusting is a chemical change because the change is permanent, is it? So you cannot get the iron back from the oxide. Oxygen and water are two essential conditions for rusting of iron. Okay. So now we can see one of the activity. Okay. Activity. What's the aim? To show that rusting of iron requires both oxygen and water. So to show that rusting of iron requires both oxygen and water. So what are the materials we need? 3 wide mouth test tubes, iron nails, boiled water, tap water, anhydrous calcium chloride, vegetable oil and rubber stoppers. Okay. So 3 wide mouth test tubes, iron nails, boiled water, tap water, anhydrous calcium chloride, vegetable oil, rubber stoppers. Okay. Then how to do this? So first step, take 3 test tubes and label them as 1, 2 and 3 and place a clean iron nail in each of them. Add a little anhydrous calcium chloride, that is the dehydrating agent, to dry the air in test tube 1. Okay, add a little anhydrous calcium chloride to dry the air in test tube 1. Pour boiled and distilled water to test tube 2 and add some vegetable oil to it to keep out the air. Boiling the water removes dissolved oxygen. In test tube 3, pour a small amount of tap water. Then fifth step is plug the mouths of all the 3 test tubes using rubber stoppers. Keep them undisturbed for 3 to 4 days. So what we can observe? Okay, so observation. The nails in test tubes 1 and 2 have not rusted, while the one in test tube 3 has rusted. So test tube 3 has rusted. So what is the conclusion? As test tubes 1 and 2 did not have moisture and oxygen respectively, there was no rusting in both these tubes. This proves that both oxygen and water are essential for rusting. Both oxygen and water are essential for rusting. Okay. So how to do this activity? First we want to take 3 test tubes and label them as 1, 2 and 3 and place that clean iron nail in each of them. Second, add a little anhydrous calcium chloride to dry the air in test tube 1. Pour boiled and distilled water to test tube 2 and add some vegetable oil to it to keep out the air. Boiling the water removes dissolved oxygen. In test tube 3, pour a small amount of tap water. Plug the mouths of all 3 test tubes using rubber stoppers. Keep them undisturbed for 3 to 4 days. So we can observe there the nails in test tube 1 and 2 have not rusted, while the one in test tube 3 has rusted. So conclusion, test tubes 1 and 2 did not have moisture and oxygen respectively. There was no rusting in both these tubes. This proves that both oxygen and water are essential for rusting. Both oxygen and water are essential for rusting. So few more examples we can see in the next class. Okay. So first, today we have learned about chemical changes. A chemical change occurs when two or more chemical substances react to produce a new substance with a different set of properties. A chemical change is permanent and such changes are occurring all around us, even within our body. So then we have learned about one of the examples of chemical change, that is reddish brown deposition on iron objects. Then so rusting, and that process, the layer that is present on that iron nail, that is called rust, and that process is called what? Rusting. Then equation becomes iron plus oxygen plus water gives iron oxide. Fe plus O2 plus H2O gives Fe2O3 XH2O. Is it? So this much we have learned today. So learn what is chemical change. Okay, what is called chemical change. So we can end this session. Okay, so stay safe. Thank you, students. Thank you.